Alrighty, welcome back everybody. We're going to get into a little bit of review today. Okay, quick little video to just get you up to speed, let you know the primary things to remember from the fall, things that will translate directly to what we do, especially coming up in the spring. So, good things to keep in mind. You're going to want to take these notes in your notebook. I'm going to have you submit just a little picture to show you did. But in all honesty, guys, you guys are going to want to keep these notes together and ready, because you're going to reference back to these things if you need it, really for the next 2-3 months. So what I cover here is going to be integral to what we do going forward. So make sure you have a handle on this. If at the end of it all you still have questions, concerns, see me after school, and we can get you up to speed. All right. So first off, the atom. Remember that when we're talking about the atom, we are talking about three major parts. Okay, the first of those parts are the protons. Okay, and let me use a little different color here because you can't see that very well. We're talking about the protons. Okay, and remember, those are in the center of the atom, in the nucleus, along with the neutrons. Okay, so you have protons and neutrons in the center of your atom, and then coordinated on the outside. Okay, this is just the nucleus. Put a little squiggly around this. Okay, then remember, on the outside is where you have the rings, where the electrons live. We will learn to know these as orbitals as we go forward, all right? But your electrons are on the outside, okay? And this is the basic structure of the atom. Remember that these things don't necessarily, collapse upon themselves, right? While these are positive and negative, the atom has an overall zero charge. Okay, remember, we assume that, at least in terms of the periodic table, the atoms, you see that protons and electrons are equal, okay, for starters, so that your atom is electrically neutral to begin. Okay, and remember, how do you determine protons? Well, you determine protons looking at the periodic table at the atomic number. Okay, so most periodic tables, you're going to have a little guide, a little key here. Okay, so as it tells you, the top number you see, in this case for sodium, okay, 11. The atomic number is 11 for sodium. Okay, hydrogen would be 1, lithium 3, beryllium 4, okay, so on and so forth. Okay, so your protons, remember, are the atomic number. And then from that, okay, protons are the atomic number. And then from that, you can also deduce the number of electrons. Okay, but remember, the atomic number is protons first, then you can infer, because that they are neutral, that protons and electrons to begin with are always equal. Okay, as far as neutrons, okay, remember that neutrons, you're going to want to look to the atomic mass. So again here, let's look at our little key. Okay, remember, the mass is on the bottom. One way to help remember that is the mass is going to be in a decimal format. Okay, you're going to have some little fraction there. Remember, that has to do with the average of all of the available isotopes. So when you average, I believe it's 3 isotopes of sodium, you come up with an average of 22.9. Okay, but to determine neutrons, remember, you're going to subtract the mass from the atomic number. Okay, so remember that if your atomic mass is protons plus neutrons. Okay, so if you want to find the number of neutrons, you're going to take the mass minus the atomic number. Okay, so if we go back to that example of sodium, okay, remember you're going to round the mass, so you'd have 23 minus 11, so that would give you 12 neutrons. Okay, always mass minus atomic number, mass minus protons. Again, the atomic mass is made up of both protons and neutrons. Okay, I know this may have been an easy part for you in the fall, but trust me, it's something that's going to come back right away, and tools that you're going to use, from now, through at least the next 2-3 months. Okay. So then, when we looked at the structure of the atom, recall that we talked a lot about the Bohr model. Remember that the Bohr model is not the actual model of the atom. Okay, it's just sort of a good teaching tool. Remember, the real model of the atom is the quantum mechanical model, or the electron cloud model. All right, but it's a little more difficult to visualize when you're using that model rather than the Bohr. So the Bohr one is what we use to teach you guys. And remember that in this model, much like I drew initially, you have your protons and neutrons in the middle in the nucleus, and you have your electrons on the outside. Now, the big question is, how many rings should your atom have? Well, if you recall that the location of the atom and the row that it's in dictate how many rings it will have. So, in this case, we have, we're going to still look at sodium here. Okay, so sodium is in the third row, so sodium will have 3 rings. Okay, so we got the first one here, 1, 2, 3. Okay, so those are 3 rings for sodium. Okay, give me 1 second. The question of how do you fill in the electrons? Okay, well, we know for sodium, I'm talking about sodium here. All right, it's going to have 11 protons. You get that straight from the periodic table. We just did the math for neutrons. Okay, it's going to have 12 neutrons. And as we said, you can assume that it will have the same number of electrons as it does protons. So you need to start filling that in. Well, how do you do that? Well, remember, there are certain rules to how many electrons can go on each ring. And those rules are governed by the periodic table. Let me use this one here, it's a little smaller. Okay, well, that's not helping either. All right, so the first row, right, corresponds to the first ring. You only have 2 atoms in that row, so only 2 electrons can go on that first ring. Okay, so we got 1, 2. Oh, and we said electrons are also 11, right? So there are 2. And then we come down to the second row. Well, we know sodium is in the third, so we're going to go all the way to the end, and you can literally count 1, 2, 3, 4, 5, 6, 7, 8. There are 8 elements in that row, hence you can put 8 electrons on that second ring. 1, 2, 3, 6, 7, 8. Okay. And now becomes the question of how many do you have left? Well, there's a couple ways you can do this. You can either count the ones you've added. So 2 plus 8 is 10. Okay, and you need 11. So that tells you that you need to add 1 more. Okay. Another way you can do that, and this gets into the number of valence electrons, and we alluded to this in the fall. We didn't get into it too deep, but we will more in the coming days. But you see here, sodium is in, as we said, the third row, but it's in the first position of that third row. Well, if it's in the first row, then you know it's going to have 1 electron on the outside, or 1 valence electron. Another tricky way to know that is that the number by the letter A will tell you how many electrons go on the outside. That doesn't work for the B's here in the middle. We're going to focus on these first 2 rows and then the last 6 at the end. So as you see, you have 1A, 2A, oops, 1A, 2A, and then you come over here to the end, you have 3A, 4, 5A, 6A, 7A, 8A. Those numbers by the letter A tell you how many electrons should be on the outermost ring, and it works that way down both the first 2 columns and the last 6. Things get a little bit different in the middle, so that's why we kind of ignore the middle. Okay, so for now, again, just assume you can either add by counting, okay, or you can look to see where it lives, okay, what spot it's in, and that will tell you how many should go on its outside ring. Remember again, those electrons on the outside ring, okay, are the valence electrons, okay. Valence electrons, the electrons on outside or the outermost ring. And those are going to become very important to us as we're going to see in bonding and in reactions, that it is these valence electrons that cause all of the action. Okay, they dictate, you know, how atoms can bond with each other. They dictate how things rearrange when it goes through a chemical reaction. And so we're not really going to be concerned about these inner electrons. Okay, we're going to be focusing more on the outside, and those are the ones again that play a very big role in bonding and in chemical reactions. Okay. Finally, to review some of the finer points of the periodic table. Okay, I would encourage you in your notes to sort of make a little faux periodic table. Okay, you don't have to have all the details and everything. You could even simply just draw a square. That would be sufficient. Okay, so you can either draw, you know, just draw a box, all right, or if you want to be a little more detailed and do something like this, okay, that'll work too. But you should have some sort of drawing just so you can relate the information that I'm going to give you here. Okay. So remember, as I've kind of alluded to already, that the rows, right, the rows going across the periodic table, okay, going from left to right, the rows are also known as periods. Okay, and that those rows and periods you can also equate to the rings, okay, in a Bohr model. Okay, whatever row the atom lives, that's going to tell you how many rings, right? So if we're looking at lithium, lithium's in the second row, it's going to have 2 rings. Silicon's in the third row, it's going to have 3 rings. Potassium's in the fourth row, it's going to have 4 rings, so on and so forth. Okay, and that's going to help you add in, as we talked about, the valence electrons, and then you're going to see once we get started up next week how that translates to bonding and then eventually to reactivity. All right. Now, the other way, the columns, or going up and down on the periodic table, okay, the columns are known as groups. Okay, and the groups, as we're going to start to see more next week, can tell you the number of valence electrons. Okay, remember that down each group you're going to have similar properties. Okay, if you recall that one video we watched, they talked about glass and how when you add different elements into it with bigger radii, it's going to change the strength of the glass. And so that's just sort of one example. But again, down each column, down each group can tell you the number of valence electrons, and it can tell you something about their reactivity and their properties, right? So everything down the first column is all going to have 1 valence electron. They're all going to have similar reactivity. Everything down the second column, all going to have 2 valence electrons. Let me zoom in here. Okay, second column, 2A, 2 valence electrons, similar reactivity. You come down here to the end, 3A, 3 valence electrons, 4A, 4 valence electrons, so on and so forth, till you get to the noble gases. And noble gases, as we're going to talk about, have 8, okay, or a full octet. That's why we, when we discussed those groups, we said that noble gases were considered inert or unreactive, and that's because they have a full complement of electrons. And again, we'll get into more of those specifics later. Okay, but again, down each column, you're going to find similarities. Those similarities start with the number of valence electrons that the atom has. Okay, and then the last thing to remember, and I hope that you guys do, that on each one of these periodic tables, okay, whether you're looking at one online or whether you are looking at a paper version, remember that you have this little staircase here. Maybe I can get my big periodic table. All right, there we go. So the staircase. Okay, remember the staircase means something. It tells you information. Okay, so to the right of the staircase, in general, you have non-metals. Okay, to the left of the staircase, you have metals. All right, and then living on the staircase, okay, or touching the staircase, get light blue here, so this guy, okay, are the metalloids. All right, and so this is a very key part. I'm sure this seems you know, rather elementary to you. Yeah, Herzog, we get it. There's metals on the left, non-metals on the right. But once we get past electron configuration into the specifics of bonding, this is going to be very important. And also when we talk about reactions, okay, simply knowing where the metals are, or you know, what is a metal, what is a non-metal, you can pretty much get through the whole unit on bonding and reactions, okay, or large chunks of it. So this is not some frivolous deal. Okay, you got to have this down. Metals to the left, non-metals to the right. You guys will see what I mean when we start covering this stuff in a couple weeks. But this is going to be very, very important to you. Okay, so you want to have a handle of where these things are located, and that can help you progress with the work that we're going to do. Okay, don't worry, you will hear me repeat it probably more than you'd like. Okay, but what's on the left, what's on the right will be very important for you guys as we go forward. Okay. All right, so hopefully you enjoyed our little recap here. You know, I will go over some of the finer points again because, you know, that's what I like to do. But as I said, guys, keep these notes. You know, I hope you're detailed in it because much of this will help you get through the next 2 units, and I'm not kidding. All right. So remember, when you're done, snap a little picture and submit it to the assignment. And that's all. Save the notes. You will use them again. Okay. I'll see you guys later.